Do you find the chemical calculations extremely confusing? Here is an easy hack to answer a reacting masses question. The equation for the reaction between nitrogen and hydrogen to produce ammonia is N2 plus 3H2 arrow 2NH3. Calculate the mass of hydrogen that is needed to produce 25 grams of ammonia. Relative atomic mass for hydrogen is 1 and for nitrogen is 14. Let's have a go at this sample question. What mass of oxygen is needed to react with 12 grams of sulfur to make sulfur dioxide? The first thing that you should do is to identify the substances that you need to carry out this calculation. We need oxygen and we also need sulfur. Because they are asking us for the mass of oxygen and they have given us the mass for sulfur. Everything else we will ignore. Now let's populate the table. The relative atomic mass of sulfur is 32. The relative molecular mass of oxygen is 32. And is there anything else that we can use to populate our table? Yes, 12 grams of sulfur. The question requires us to calculate the mass of oxygen needed. However, we do not have enough information to do that calculation. So let's go back to our sulfur. We need to find the number of moles of sulfur. Using the triangle, if you cover moles on your triangle, the equation will be moles is equal to mass over relative formula mass or relative atomic mass. So let's perform that calculation. 12 over 32, 0.375 moles. Let's go back to our balanced equation and we're going to compare sulfur and oxygen. For every sulfur, we have one oxygen molecule, and so we say there is a 1-to-1 mole ratio. So if we have 1 mole of sulfur, we have 1 mole of oxygen. If we have 0.375 moles of sulfur, then we have 0.375 moles of oxygen. Well done. For the final part, we need to calculate the mass of oxygen. So we cover mass on the triangle and the formula is mass is equal to moles times relative molecular mass. So 32 times 0.375 and your answer is 12 grams. Well done. For the exam question, you need to identify the two substances that you need to carry out the calculations. The question is asking us for the mass of hydrogen, so we're going to highlight hydrogen. And it has given us the mass of ammonia, and so we're going to highlight ammonia as well. Everything else in the equation, we are going to ignore. Let's populate the table. What is the relative molecular mass of hydrogen gas? Good. 2. What about ammonia? 17. Well done. Is there any other information that we can use to populate the table? Good. We have 25 grams of ammonia. Now, we're going to use our triangle again. Cover moles on your triangle. And the formula is moles is equal to mass over relative molecular mass. 25 over 17 will give you 1.47 moles. Now let's look at the mole ratio. The mole ratio is a bit different in this one. It's not a 1-to-1 mole ratio or a 2-to-2 mole ratio. For this one, it is 3-to-2. For every 3 hydrogen molecule, you have 2 ammonia molecule. And so we need to use a fraction to calculate the number of moles for hydrogen. So we're going to do 3 over 2 times 1.47. And your answer is 2.205 moles. Now, how do we find the mass of hydrogen from this? Cover mass on your triangle, and that is moles times relative molecular mass. And therefore, it is 2 times 2.205, which gives you your final answer as 4.41. Well done. In the video, I used the words relative molecular mass, relative formula mass, and relative atomic mass. Please note that even though the calculations are the same, we use relative atomic mass when we're referring to elements, relative molecular mass when we're referring to covalent compounds, and relative formula mass when we are referring to ionic compounds.